Good morning, one and all present here. I'm Nandinidhi, working as an assistant professor in SNS College of Engineering in the Department of Computer Science and Technology. Today, we are going to see a topic on relational data model in DBMS. What does a relational data model stands for? Our DBMS stands for Relational Database Management System. It is the basis for the SQL and for all modern databases systems like SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access. A relational database management system is a database management system that is based on the relational model as introduced by E.F. Codd. A table is being explained with the help of some example which consists of a student ID, student name, age, address, and their salary. The data in RDBMS is stored in database object called tables. The table is a collection of related data in query and it is consists of columns and rows. In this we have 7 members details which have been stored in this table. And the field that we are going to use here I have explained earlier: ID, name, age, address, and salary. The field is the customer table. The table is known as a customer table. A field is a column in a table that is designed to maintain the specific information about every record in the table. Record or row. What is a record or a row? A record, always called a row of tables, is each individual entry that exists in the table. For example, first ID is 1, his name is Ramesh, his age is 32, he is from Ahmedabad, and his salary is 2000 rupees. And the column reference as a column is represented in vertical entity in a table that contains all information associated with a specific field in a table. For example, a column in the customer table is addressed with represents location, description, and would consist of the following. For example, in a column manner, an address has been here. It will consist of Ahmedabad, Delhi, Kotak, Mumbai, Bhopal, MP, and Indore. And second one is a null value. A null value in a table is a value in a field that appears to be a blank, which means a field with a null value is a field with no value. It consists of either 0 or no values have been there. It is a very important to understand that a null value is different than a 0 value or a field that contains the space. A field with a null value is one that has been left blank during the record creation. In an SQL constraints are the rule enforced on a data column on the table. It consists of some rules. That rules has some limits of data in a table, and it is used for their accuracy, reliability of data in the databases. Constraints could be column level or table level. Column level constraints are applied only to one column, whereas table level constraints are applied to the whole table. And then data integrity, entity integrity. There are no duplicate rows in a table. Domain integrity enforces the entity for valid giving a column by restricting the type, the format of the range of the values. And referential integrity, the referential integrity, rows cannot be deleted which are used by other records. An example has been given, shown in the figure. Next one is the codes 12 rule. There is a 12 rule which consists of the codes. Dr. Agar F. Codd, after his executive research on the relational model of database system, he come up with 12 rules of his own, which according to him a database must obey in order to be regarded as a true relational databases. These rules can be applied on any database systems that manages stores data using only its relational capability. This is a founder rule which acts as base of other rules. First rule, rule 1 is known as information rule. The data stored in a database, may it be user data or metadata, must be a value of some table cell. It consists of some data that must contain some values in a table. Everything in a database must be stored in a table format. First one, data must be in a meta table format and it should be stored in a table format. Rule 2, guaranteed access rule. Every single data element is guaranteed to be accessible logically with a combination of table name, primary key, and attribute name. No other means such as pointers can be used to access the data. Rule 3 is known as systematic treatment of null values. The null values in a database must be given in a systematic and uniform treatment. This is a very important rule because a null can be integrated as on the following data which is missing, is not known, or data is not applicable. Rule 4 is an active online catalog. This structure describes of the entire database must be stored in an online catalog known as a data dictionary, which can be accessed by authorized users. Users can use the same query language to access the catalog which they use to access the database items. Rule 5 is comprehensive data sub-language rule. A database can only be accessed using a language having a linear syntax that supports data definition, data manipulation, and transaction management operations. These languages can be used directly or by means of some application. If the database allows the access to data without any help of this language, then it is considered as a violation. The rule 6, viewing updated rule. All the view of databases which can theoretically be updated must also be updated by the system. Next one is rule 7, high level insert, update and delete rule. A database must support high level insert, update and deletion. This not be limited to a single row. That is, it must also support the union, intersection and minus operations to yield a set of data records. Next one is rule 8, physical data independence. The data stored in a database must be independent of the applications that access the database. Any changes in the physical structure of a database must be not have any impact on how the data has been accessed by the external applications. And the physical data independence says that if a database consists of a table, it must be accessed in an external application, not by an internal application. Next one is rule 9. It is a logical data independence. The logical data in database must be independent of the user's view. Any changes in logical data must not affect the application user it. For example, if two